Welcome to this class. This is statistics Form 3 work. So we've covered statistics in Form 1. We did it in Form 2 and now this is Form 3. So today's class should be interesting, more interesting than the rest. So if you need, you must have a pen and a paper or a pencil, something you can use to sketch from. Then you'll also need to have a set nearby so that you can perfect these, you can draw them perfectly. But for now, you just need to draw, sketch for understanding. So we are going to look at still analysis, interpretation, and presentation. And today we are going to look at the polygraph. We're going to look at the cumulative bar graphs, which are around there. We have the proportional circles, pie charts. Let's see what we can learn today. So let me get my tools ready. So we are going to look at a compound bar graph. Already we looked at what a bar graph is. So I'll try sketch it out here. Is a sketch. Very poor sketch. But it's for learning purposes. So this is a bar graph. So what could a compound bar graph mean? I know you know, so let me add something to make it compound. So let's do some shading. Weird shading. So that, let's try. Oh, sorry. I've cleared my work. But we had noticed what I was trying to draw there. Maybe I can try sketch a better one quickly. Let's assume they're perfect. Let's add one more. So assuming we are comparing, let's say this is 1999. This is 2000. This is 2001. And we were comparing, maybe this is wheat. Let's get, this is, let's say it's maize. Let's get something else, maybe sorghum. Comparing how the production over these years. So in 201, let's assume there was only sorghum. Let's change this. Of course, you shade them in a better manner. This is just a sketch. So this is what a compound bar graph would look like. So the advantages of this would be it's easy to construct, but the key advantage would be there is easy comparison for the same components in different bars because of uniform shading. So in this case, let's look at sorghum, uniformly shaded. The maize, uniformly shaded. The wheat, which we forgot to draw it somewhere, to shade it somewhere, uniformly shaded. It's easy to interpret because bars are shaded differently. Also, the total value of the bar can be identified easily. So for example, 1999 we had the highest production and the lowest production was in 201. So Disadvantages, it doesn't show the trend of components, that is change over time. Also can be used to show many components as there is limited space upward. So there will be a challenge to add maybe rice and or beans, or those other cereals. So tedious as there is a lot of calculation work involved. It's true. So you have to calculate from the total production over the years. You calculate how the height of every bar represented by the years, and then you're also going to calculate the individual portions of the items you're mapping out. And it's not easy to trace individual contribution made by members of the same bar. So it's just a bias. We have a scale over this side, but there isn't much we can tell. We cannot get the numerical contribution easily. And finally, poor choice of vertical scale causes exaggeration of bus lengths, leading to wrong conclusion. So I think we were quite decent with the scale, but a wrong one would have the bars too high to maybe fit on our scales. So we look at the proportional circles, but before that, let's look at the pie charts. And I'll try to sketch. It's not perfect, it should be perfect. So we're trying to use the same logic we used in the previous example. So let's use red. So we had sorghum taking up that much, then we have wheat taking that much, and then we have maize. Then we are supposed to actually shade them well differently. Yes, and that's a pie chart. So what we do, we get the total value, calculate derive degrees from that data, and then we calculate the values which have been converted into degrees. So for example, if we had if the total was 6,000, so and maize was 4,000, so 4,000 over 6,000 multiplied by 360, that should give us the degree. Then let's now look at the advantages. It gives a clear visual impression. It's easy to draw, can be used to represent varying types of data, easy to read and interpret, as segments are arranged in descending order and are also well shaded. It's easy to compare individual segments. The disadvantages would be difficult to interpret if segments are many. So this is easy. If we had about 5 segments, it would be quite tedious. Also, it's tedious due to the a lot of mathematical calculations and marking out of degrees, angles involved. It can be used to show trend or change over a certain period. Also, small quantities or decimals may not be easily represented. For example, if we computed 1 and we got something like 1 degree, that would be quite difficult to draw over here. And from this, now let's look at proportional circles, which are actually a level higher from the pie charts. So I hope you're following along. Your circles should be perfect. Make sure when you're practicing these, you have a set with you. So let's say this is 2001, this is 19, 2000. That is 2000, and this is 2000. Sorry, 1999. This is 1999. So we are representing the same data, probably this data that we try to represent here. So we are going to, like in the pie charts we just drew, we're going to get the angles of the individual values. We'll try to do that quickly. So assuming it was not perfect. This one. So let's discuss. That's the idea. So they give a good visual impression. It's easy to compare various components. It's simple to construct. It's easy to interpret as segments are arranged in descending order. Can be used to represent various types of data. Disadvantages is it's tedious in calculation and measurement of angles. Actual values represented by each component can't be known at a glance. Difficult to accurately measure and draw sectors whose values are too small. Comparison can be difficult if the circles represent values which are almost equal. For example, 2000 and 1999, they're too close. So how this is done, you first you determine the radius of the circles by finding the square roots of the totals. Then you obtain a scale. Then you proceed by using your pair of compasses to draw circles of different radius, representing the total production. Well, the production of the idea. Then you convert the component values into degrees. So convert the wheat, the sorghum, the maize degrees. That's all for this statistics. So linked below is the document which has these well drawn out. So this was intended to have the class quite more interesting and more interactive. So we'll see you in the next class. And that should be map work on 3.